Hi, Shada. I'm going to try to quickly do a couple of these questions for you to get you started. And I've also attached to the email a screenshot from the Formula to Success resource from the Academic Skills website. And the screenshot is of all the trig identities that you need to know before starting this out. So if you need to use that as a reference, then you'll have it there handy. So let's start with something like 31. The problem is, I think what we have to do first is just identify the problem and go from there in terms of how do we eliminate the problem. So sorry, I'm just reading as I'm talking here. So starting with the limit as t or as theta equals 0 approaches 0. Looky. Starting with that, the problem is that if we put a 0 in for theta, whenever we're taking sine of theta, we're going to get 0. So if you think of the graph of the sine function, it starts at 0 and ends at 0. So sine of 0 is 0. So that's really the problem. So the first step in doing these questions is to identify what's the problem. And then the second step is to figure out how do we remove that problem. And so what you're going to do here, I think the easiest way to do this is to use your identity for the Pythagorean identity, 1 minus cos squared theta equals sine squared theta. Now I'm going to leave it up to you to go back and write in all your lim as theta approaches 0 and all that. I'm just going to show you how to deal with getting rid of the sine 2 theta in the bottom, okay? So the first thing I want to do is I want to recognize that sine 2 theta is 2 sine theta cos theta. The next thing I want to do is I know I want to get rid of this sine theta, and I don't have any sine thetas in the numerator, so I've got to create one. So I can do anything I want to my equation as long as I do it to the top and the bottom. And this is what I want to do to my equation this time. I'll show you why I want to do that. The reason why is that when I multiply the top two factors, I end up with 1 minus cos squared theta. I did that on purpose. I made like a difference of squares here to what I had here. I did that for a particular reason, and the reason is that 1 minus cos squared theta is one of our Pythagorean identities. So that should be a plus there. I know that that equals sine squared theta, and that's the key to this whole solution, because now I can use that sine squared theta. It's almost like a game. I'm going to use him to knock out the other guy. I'm going to take one of the sines there and knock out this guy in the denominator. And so what I've ended up with is sine of theta on the top over 2 times the cos of theta times 1 plus cos theta. It looks nothing like what we started with, I know. But the beauty of it is that now I can substitute theta equals 0 into here, and I'm not going to get a 0 in the denominator. I'm still going to get a 0 in the numerator, but I'm not going to get a 0 in the denominator, and that's the problem, is zeros in the denominator are very, very bad because they give us undefined values, and we can't have that. Okay? So it turns out for 31 that the limit is 0. So I'm going to pick one more and do it for you and send this off to you so that you can get working on it, and I will check my my emails over the weekend as well. So I'm going to stop here, and I'm going to actually send you a second video because I'm not quite sure if I can change pages without wrecking everything I've done. All right.